Welcome back to Wonder Scope, where we dive into the mysteries of the universe. But today, we're not just diving, we're falling. And not just anywhere, but straight into the most terrifying and fascinating phenomenon in the cosmos, a black hole. Hold on. Before you panic and start double-checking your interstellar travel plans for any accidental detours into a black hole, let me assure you, this is purely hypothetical. At least for now. Here's the thing. Black holes are some of the most mind-bending objects in the universe. They break the rules of physics, twist reality, and stretch your imagination. Or, well, stretch you if you get too close. But what actually happens if you fall into one? Could you survive? Or is it the ultimate one-way ticket to cosmic oblivion? Buckle up, because today we're going on a journey into the heart of a black hole, where gravity reigns supreme and reality itself unravels. First things first, what even is a black hole? Picture this. Take an entire star, one many times the size of our sun, and compress it down into a point so small it's beyond comprehension. A single point smaller than a grain of sand, yet with a mass millions, or even billions, of times greater than the sun. What you get is a black hole. In simple terms, a black hole is a region of space-time where gravity is so intense that not even light, the fastest thing in the universe, can escape. That's why they're called black holes. They're like cosmic invisibility cloaks. You can't see them directly, but their effects on the surrounding space are impossible to miss. They warp space-time itself, creating what can only be described as a bottomless pit. Imagine a trampoline with a bowling ball in the center. Now replace the bowling ball with something infinitely heavy, and you've got the idea. Except, instead of just curving the fabric of space-time, black holes twist it, stretch it, and pull it down infinitely. It's like quicksand. But instead of just pulling you in, it also distorts time, space, and the very laws of physics. Black holes are born in the most dramatic way possible, when a massive star dies. You see, stars are held together by a delicate balance. The outward pressure from nuclear fusion counteracts the inward pull of gravity. But when a star runs out of fuel, gravity takes over. The star collapses under its own weight, compressing its mass into an unimaginably small volume. The result? A black hole. This process creates stellar black holes, the babies of the black hole family. They're relatively small, just a few kilometers across, but their gravitational pull is off the charts. To put it in perspective, a stellar black hole with just 5 times the mass of the Sun can have gravity 310 billion times stronger than Earth's. That's enough to crush you, or stretch you, long before you reach its center. At the other end of the spectrum, we have supermassive black holes, which sit at the centers of galaxies, including our own Milky Way. These giants can have masses billions of times greater than the Sun. Take Phoenix A, for example. This cosmic heavyweight is over 100 billion times the mass of our Sun. To visualize its size, the distance from its singularity to its event horizon is 300 billion kilometers. That's twice the distance from the Sun to Neptune. Let's imagine you're an adventurous soul exploring the galaxy in your state-of-the-art spaceship. You're cruising through space, marveling at the stars, when you spot something strange. A dark, swirling patch of space surrounded by a glowing disk of light. You've stumbled upon a black hole. From a safe distance, it's mesmerizing. The glowing food tray around the black hole, called the accretion disk, is made up of gas, dust, and unlucky stars torn apart by the black hole's immense gravity. This material spins at incredible speeds, heating up to millions of degrees. How hot, you ask? Hot enough to emit powerful X-rays. In fact, if your spaceship strayed too close to the accretion disk, you'd be fried before you could even say, "What's for dinner?" But let's assume this is an unusually clean black hole with no accretion disk. You continue your journey, inching closer to the event horizon, the point of no return. If you're falling into a stellar black hole, the phenomenon of spaghettification will occur even before you cross the event horizon. As you approach the event horizon, you'll start to notice changes. The gravitational force isn't just intense, it's uneven. For example, if your feet are closer to the black hole than your head, the pull on your feet could be thousands of billions of times stronger. This difference creates an extreme tidal force, stretching you like a strand of spaghetti while compressing you horizontally. Scientists call this phenomenon spaghettification. You'll be torn apart, molecule by molecule, atom by atom, until all that remains is a stream of subatomic particles, a cosmic spaghetti strand. Tasty? Not at all. Terrifying? Absolutely. As mentioned earlier, the distance from the event horizon to the singularity of a stellar black hole ranges from a few kilometers to a few dozen kilometers, much smaller than the distance from the event horizon to the singularity of supermassive black holes, which can span hundreds of billions of kilometers. And since gravity is inversely proportional to the square of the distance, if you were to fall into a supermassive black hole like Phoenix A, the story would be different. Here, the gravitational pull near the event horizon is gentler, roughly 15.5 times that of Earth's gravity, allowing you to cross it intact. But don't celebrate just yet. Your fate is still sealed. So, you've made it to the event horizon, the legendary point of no return. What happens now? Surprisingly, absolutely nothing noticeable at first. The event horizon isn't some wall or physical boundary. It's simply the threshold where gravity becomes so strong that even light, traveling at 299,792 kilometers per second, cannot escape. Once you cross it, all roads lead to one place, the singularity. But here's where things get bizarre. To you, time feels completely normal. Your spaceship is functioning fine. Your watch ticks forward as usual, and you see no immediate signs of doom. You might even feel a sense of calm, until the weird visuals start. As you look back toward the universe outside the black hole, the light bending around the event horizon creates an otherworldly spectacle. Gravitational lensing twists and stretches the image of the cosmos behind you. Stars appear distorted, smeared into streaks of light. If the black hole is spinning, and most black holes are, it can drag spacetime itself along with it, creating a swirling whirlpool of distorted light called the photon sphere. For an outside observer, let's say your friend at mission control, you're no longer moving forward. Instead, they see you frozen in time at the event horizon. Why? Because the immense gravity is slowing down the light escaping from you. The light waves stretch into longer and longer wavelengths, shifting into the red part of the spectrum. This is called gravitational redshift. Over time, you fade from view entirely as the light waves lose energy and fall below the visible spectrum. To your friend, it's as if you've been erased from existence. But from your perspective, you're falling deeper, blissfully unaware that the rest of the universe thinks you've already disappeared. So, what's inside a black hole? What are you falling toward? The answer is both thrilling and terrifying. The singularity. The singularity is the very heart of the black hole, a point of infinite density where all the black hole's mass is concentrated. This is where spacetime itself is thought to collapse, and the laws of physics break down completely. Everything we understand about the universe, gravity, time, space, stops making sense. Scientists describe the singularity as a place where density becomes infinite and the curvature of spacetime becomes infinitely steep. In simpler terms, it's the ultimate cosmic paradox. But what actually happens at the singularity? That's the big mystery. Some theories suggest it could be the end of existence itself, a place where matter is crushed out of existence, leaving behind only energy. Others propose that the singularity might act as a portal to another universe. This idea ties into the concept of wormholes, theoretical shortcuts through spacetime that could connect two distant points, or even two entirely different universes. There's also the holographic principle, which proposes that everything that falls into a black hole, every particle of matter, every photon of light, is not truly lost. Instead, all the information about it is stored on the event horizon, like a cosmic hard drive. This theory suggests that black holes aren't just destroyers. They could also be the ultimate archivists of the universe. Unfortunately, none of these theories can be tested because no information can escape a black hole. Once you reach the singularity, you've crossed the final frontier. Every path leads inward, and there's no turning back. You'd be compressed into an unimaginably tiny space, joining the rest of the black hole's mass in a state beyond our understanding. As you fall deeper into the black hole, time begins to behave strangely. This is due to gravitational time dilation, a phenomenon predicted by Einstein's theory of relativity. Essentially, the stronger the gravity, the slower time moves. From your perspective inside the black hole, time feels normal. Your seconds tick by at the usual pace, and you wouldn't notice anything unusual. But to the outside universe, time appears to grind to a halt for you. If someone were watching you from a safe distance, they'd see your clock ticking slower and slower as you approach the event horizon. By the time you cross it, your clock would appear to stop completely. Here's the crazy part. Because time slows so much inside the black hole, you'd witness the universe outside speeding up. Stars would age and die, galaxies would swirl and collide, and entire civilizations might rise and fall. Billions of years could pass in what feels like mere seconds to you. And then there's Hawking radiation. Proposed by physicist Stephen Hawking, this phenomenon suggests that black holes slowly lose mass over time by emitting tiny amounts of radiation. Over trillions of years, a black hole could evaporate entirely. If you're falling into one, you might witness the black hole's final moments, the evaporation of one of the most powerful objects in the universe, before your journey ends at the singularity. This paradoxical relationship between time and gravity is one of the reasons black holes are so fascinating. They don't just distort space, they warp the very fabric of reality itself. You might wonder, why should we care about black holes if they're just giant cosmic death traps? The answer is simple. Black holes are essential to the universe. Supermassive black holes anchor galaxies, keeping billions of stars in orbit. Without them, the structure of the cosmos as we know it wouldn't exist. In fact, our Milky Way has its very own supermassive black hole, Sagittarius A, with a mass about 4 million times that of the Sun. It silently orchestrates the movement of our galaxy. Black holes also push the boundaries of science. They test Einstein's theory of relativity, give insights into the fabric of space-time, and challenge our understanding of quantum mechanics. Reconciling these two fields, relativity and quantum mechanics, is one of the biggest unsolved puzzles in physics, and black holes may hold the key. Beyond their scientific importance, black holes inspire awe. They remind us how vast, strange, and mysterious the universe truly is. Studying them isn't just about understanding the cosmos, it's about expanding the limits of human knowledge and our place in the universe. Now, let me ask you this. If you had the chance, would you take a one-way trip into a black hole? Sure, it's a guaranteed way to witness the most extreme phenomena in the universe. But is it worth the ultimate sacrifice? Let me know your thoughts in the comments below. Black holes may be terrifying, but they're also a reminder of how vast and mysterious our universe truly is. If you enjoyed this journey through the cosmos, don't forget to like the video, subscribe to Wonderscope, and hit the notification bell for more mind-blowing content. Until next time, keep wondering.